So now we're going to go ahead and talk a little bit about similarity. So the most basic definition of similarity of two shapes, you have two shapes, is that they are two of the same shape. So the two shapes are the same, but they're different sizes. So one will be bigger or smaller than the other. So there's a dilation factor. There's some sort of scale factor. Now, for them to be the same shape, just a note, they have to have matching angles. So all angles must, or their angles must match. So you'll notice this picture, these two shapes are similar because angle A matches with angle E. So in fact, when you write a similarity statement, you use this little squiggle right here. And if we start with angle A for this one, we'd have to start with angle E. B matches with F. C matches with G. So those two match. And then D and H are matching. So we'd say these two figures are similar. Now, we need to find scale factors, and that's what we're going to be doing next. And it depends on which direction you're going. So if I tell you to go from this big one to the small one, what you do is you find corresponding sides that are similar to each other, just different sizes. So this goes from 6 to 3. That means our scale factor, if we're going from big to small, would be 3/6 or 1/2, because you're splitting in half. Or sometimes they'll write it this way. So if you're going from big to small, we would say it's 2 to 1. Every length of 2 on this big shape would be a length of 1 on the small shape. Okay. So those are two different ways to write it. I'm going to have you guys write it as ratios because I don't know if you have a lot of experience with ratios, but that's what we're going to do right here. So all of these shapes that I've given you in these pictures are similar. They just have different sides. These are not drawn to scale, by the way, because these two look like they're the exact same size, but the shape or the side lengths are different. So once again, you find a corresponding, it doesn't matter what corresponding side you're going to pick. So it would be 16 and 40, for instance. And we're going from the smaller shape to the bigger. Okay, so that means we're getting bigger, so the big shape will go on the top, so 40/16, so big on top. And then you're going to simplify that fraction. So 40/16, both of those, if you're not sure of something, just find something you can divide both of them by until you can't divide anymore. So those are both divisible by 2. Well, 20 and 8 are also both divisible by 2, so I'm just going to keep going until I can't. So that's 10/4. And oh look, those are both divisible by 2. Oops, forgot to write a 2. So that's 5/2. So our scale factor would be 5/2, or the way you would write it, since we're going small to big, so it goes small to big, you would write it this way. You'd write the smaller number to the bigger number. Great. So this first one's telling you what you would multiply the small ones by to get to the big one. The other one's just saying the ratio of the two. Let's do another. Same idea. You just find two that match. So this shorter side matches with this other one's shorter side. So those are a good option. Once again, we're going from the smaller to the bigger. So since we're getting to the bigger one, you start with the bigger and put it over the smaller. And then we do the same idea where just keep finding things you can divide them by. Now I'm going to do a bigger number because I know both of these are divisible by 4. So that would give me 6/5. And 6 and 5, I can't divide those by anything, so I know that's done. So if I go small to big, I would do the small number to the big number like this. So notice I just use those exact same numbers after it's simplified. Cool. Same idea with number 7. So pick whichever one. Sometimes it's nice to pick like smaller numbers. So these two are smaller and they relate to each other. It's the smallest side. So I'll do my 8 over 6. Those are both divisible by 2, so we have 4/3. If I divide them both by 2. And 4/3 does not go down anymore. So if I do my ratio, it would be 3/4. Now I'm showing the fractions because next time we're going to use the fractions, but I'll show you how you can just go straight to the ratio without doing that. It's the same idea. I'm going to go ahead and pick the smaller sides again for this one. And you would just do 8 to 10, so you do the small to the big one. And then you still find things, common factors you can divide by. So I can divide this by 2 and that one by 2. So that'd give me 4 to 5, and I'd actually be done because they don't divide anymore. So notice how you don't actually have to do the fraction. I was just showing you as an introduction to next time's lesson a little bit. So that is it.